Yeah.
We have now got Dr. Emily Grossman, who is going to be doing some sciencey stuff for us. So I'm going to pass you over. Thank you very much. Can you go, Emily?
We also have one of these amazing chairs. These chairs that
Hi,
fold
good
up,
morning,
have a look.
everyone.
You can
Well,
make it
actually,
yourself.
Good afternoon.
Good afternoon. We have a scientist here, Dr.
So,
Emily.
my name's Emily, and I'm a scientist.
Yes.
And I love science, because science is all about asking why. It's all about finding out about the world. It's all about trying to figure stuff out. Ever since I was tiny, my favourite word was why. I was always asking questions. It was like, what does this mean? How does this work? Why does this happen? And that is what is exciting about discovering about the world around us. What I do now is I've been a scientist, I've also been an actress, I've also been a science teacher in a school, and now I'm what's called a science communicator, which means I've got the best job in the world, because I get to go around talking to people at schools and in universities and at events and festivals and explaining to them all of the fascinating, exciting stuff in the world around us that's all to do with science. What was that? I would love to come to your school.
Hey.
I will tell you how we can make that happen in just some short time. But yeah, that's exactly what I do. I go into primary schools and secondary schools and universities, and I enthuse young people about the joy of science, about the joy of discovering the world. So what I'd like to do with you today is I'd like to tell you about some of my favourite weird facts about the world around us, and also to talk to you about how we're all related and linked to the natural world, to the world around us, which brings us really to why we're all here today. Because we're here today because we love the natural world, because we love life, because we love all creatures on this earth, and we want to make sure that we protect and look after this beautiful planet that is our home. But to begin with, are any of you ticklish?
Yeah.
Who here is really, really ticklish? Who here is really, 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 really ticklish? Dinosaur over there is really ticklish. Did you know that you can block a tickle?
No. What?
There is something that you can do to stop a tickle from feeling ticklish. Would you like to know what it is?
Yes, please.
Thought you might. But you see, I'm not going to tell you the answer. Because, as I said, for me, what science is all about is about figuring stuff out and trying to work things out for ourselves. Which is why I've just written a book which is called Brain Fizzing Facts, Awesome Science Questions Answered. And it's all about trying to work out the answers for ourselves. So I'm going to help you to come up with the solution for how you can block a tickle. But we're going to do it together. And in order to do this is something I talk a lot about in my book, is that I need you to really believe me that science isn't about getting things right. It isn't about knowing the most or doing the best or being the most confident. It's about having a go. And it's about making mistakes. And it's about trying things and then trying again. We learn the best, the most, when we get things wrong. Can anyone tell me a really important example of a really famous scientist who made an amazing discovery by mucking up his experiment, by making a mistake and by getting things wrong?
Edison.
Yes.
Einstein.
Albert Einstein, what can you tell me about him?
I forgot some of the facts, but it's just a famous scientist.
That's a famous scientist, great. Albert Einstein is one of my favourite scientists, because my favourite thing that Albert Einstein said is he said, imagination is more important than knowledge. He said, I believe in intuitions and inspirations. Sometimes I feel I'm right, I do not know I am.
Yeah.
And that for me is a really important part of science, is it's about being creative, it's about using our imagination, it's about dreaming and wondering about the world around us.
And like another little thing, if at first you don't succeed, try again.
Brilliant! And that really is a wonderful phrase that kind of embodies what science is all about. But I've got another favourite scientist. I've got lots of favourite scientists.
Edison.
Another favourite scientist.
Edison.
Edison, tell us about Edison, Mr. Man behind the camera.
Mr. Man behind the camera, yes. So Edison, he tried, 300 different ways to make a light bulb, and all of them failed. But he didn't think the failure as a failure, it was just another thing that didn't work, which got him one step closer to knowing what else won't work until he will get the one that does work.
Absolutely. Science actually shows that our brains are... can anyone tell me where I can stand so it doesn't keep squeaking so much?
Just on the side. If you're in front of it,
Yeah.
it gives feedback. Yay.
Am I this way? It's still making horrible noises. Okay. That's not quite working either. Anyone? Anyone know about sound? Point what? No.
If you come behind the line of the speaker, then the sound from the speaker.
Behind the line of the speaker. Oh, that's a bit of basic physics. That's to do with amplification and interference.
Yay!
Okay, so one of my favourite scientists that I was telling you about earlier. No, you were talking about Edison. Sorry, I got thrown off.
No.
Edison, great example of someone who tried many times to do something, but he didn't give up, did he? He kept going. And science studies have shown that our brains make more connections when we get stuff wrong and we learn and we try again than actually when we get stuff right. So really, it doesn't matter whether you're top of the class or the best person or someone who thinks they know all the answers. It's actually about just having a go. My favourite example of this is a scientist called Alexander Fleming. Now, you might have heard of Alexander Fleming, but Alexander Fleming was doing an experiment with bacteria. Now, he was doing this a long time ago, and he was doing it at a time when there were lots of people in the world who were getting very sick and very ill from bacterial infections that would kill them in hospitals. We couldn't just cure them like we do today. And now at this time, he was doing an experiment with some of these bacteria, and he was growing them on what scientists call a petri dish, a little plate with food on where the bacteria would grow. Now, he did something which you could probably think was a bit of a mistake. He sort of mucked up. What he did is he left his petri dish on the bench in his laboratory by an open window and went on holiday. Now, when you leave food by an open window and go on holiday, it rots, exactly. So this food went mouldy. And he got back from his holiday. I don't know if he actually went on holiday, but that's what I think happened. What's that? Thank you,
Penicillin, I mean.
So he got back from his holiday.
Sorry.
And he walked into his laboratory and he looked at his little plate with bacteria on it and he found it was covered in mould. And he went, oh no. I've made a mistake. I'm going to be in big trouble. I've messed up my experiment. I'm going to have to throw it away. But before he did that, he looked at it again. And he looked at it and he said one of probably the most important phrases in science. Now, some people think an important phrase in science is, Eureka! I've got it! But no. By the way, who said Eureka? Anyone?
Einstein. No.
You said it.
Oh, yeah.
Who did?
Archimedes.
Once or twice you said it.
Archimedes.
Archimedes said it. Archimedes said
You
it when he got in
win,
his bath
yeah.
and the water spilled over the side and he went, Eureka! I understand about displacement of water. However, what Fleming said, I think, is actually probably a much more important phrase in science, which was, oh, that's funny.
Yes, that's weird.
Because he looked at this little dish,
Strange.
and before he threw it away, even though it was a mucked up experiment, so he thought, before he threw it away, he went, oh, that's a bit odd. Because what he found is around the bacteria, where the fluffy bits of mould had fallen on the plate, around those bits of mould, the bacteria had died. And he thought, gosh, that's a bit odd. Because at that point, there was nothing known that could kill bacteria. And he had the presence of mind, the imagination, and the ability to look past his mistake and go, this is very interesting. And him and his pals went on to isolate a chemical from this mold that was able to kill bacteria. Anyone know what that chemical was called?
Penicillin.
Anyone? Penicillin! Penicillin was the first antibiotic, and it went on to save millions of lives. So this just shows us, doesn't it, that science is about just having a go and trying stuff out. So, with that in mind, let's come back to this idea that you can block a tickle. So let's have a go and make a guess and try stuff out to see if we can figure out what the answer might be. So can anyone make a guess as to maybe how you could block a tickle? Yes. Was that? With more tickles? Oh, that could be good. So what, tickle the person who's tickling you? That could be quite cool, couldn't it?
Warm water.
Yeah? Get a lot of tickles so it kind of... And then what? So basically you kind of make yourself immune to being tickled. So if you get tickled enough, maybe it doesn't tickle anymore. I love this idea.
Desensitization.
I'm not going to try this one out because it might take some time. Okay, yeah, go on.
If you're already laughing, then the tickle is...
If you're already laughing, brilliant. So what we have here is what in science we call a hypothesis, an idea, a suggestion. And like all good science, when we have a suggestion as to what the answer could be, what do we have to do?
Test.
To test it, we have to do a
Empirical test.
So,
Experiment.
for my experiment, I'm going to need a volunteer. Now, before you volunteer, I want you to
One
check
of the
two
quiet
things.
hands.
First of all, my volunteer needs to be ticklish under your arms specifically. Second of all, you need to not mind being tickled under your arms by me, in front of all these people here, and in front of the camera.
Hi again.
So,
So,
moms and dads, if you're
those that
happy
are
with
just
this,
joining in, this is
guys,
Extinction
bring up.
Rebellion. We are here at the Department of Education.
We're about to do a really good experiment.
About to
here,
do a very
ladies.
good experiment. We are.
Okay, cool.
Let's do
So,
it.
Mums and dads, as long as you don't mind this being possibly in photos and videos that are public. Okay, so do we have a volunteer down here? Brilliant, thank you. What's your
So
name?
those just joining, we're at the Department of Education.
Lyra, nice to meet you. Okay,
Asking them to
brilliant.
teach the
So,
truth.
We had a suggestion that to block a tickle, we could get you to just laugh already and then see if it doesn't tickle so much. I love this idea. I've never heard that suggestion before. So, like all good science experiments, the first thing we need to do is we need to make sure that this is going to be what we call a fair test. You might have heard of that phrase before. What it means is we need to make sure, in this case, that Lyra is indeed ticklish before we see if she can block the tickle, which unfortunately means you're going to have to let me tickle you just to check you're ticklish. Are we okay with this? Okay, great. So, if you turn around to face everybody, now in a moment, I'm going to ask you to put your arms in the air, and I'm going to count to 3, and then I'm going to tickle you under your arms. Are we okay with this? Are we okay with this? Okay, great. All right then, so Lyra, arms in the air.
3, 2, 1. Tickle, 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 tickle.
Is Lyra ticklish?
Yeah.
Then we can start the experiment. Okay, Lyra, so we had a suggestion, a hypothesis, that to block the tickle, we could ask you to laugh already. So I'm going to do exactly the same, but I want you to already be laughing, even if it's just pretend laughing. Ready?
Ooh.
Less ticklish.
Yes.
So clever. So what we've seen here is the power of sort of mind over matter. We can kind of distract Lyra's brain from already laughing to actually make her kind of be less ticklish to the actual tickle. Really clever. Have we got any other ideas of something even better that we could do? Yes.
What if people are teaching you already and you don't even feel a thing?
So if someone's already tickling you, then maybe Oh, that's a good point.
Over
That's a
tickling.
good point.
Tickling, tickling.
So tickling someone who's already being tickled. That's great. Yeah, you got an idea?
Evil
So like,
scientist.
like if you're already being tickled and like by a blade of grass or something or a feather, and you go up to tickle them, it might not like affect them because they're already being tickled.
Love
Tickle
it. So
somewhere
it's sort of
else.
enhancement on this idea over here. Brilliant. I love all these suggestions. I'm going to give you a clue as to something that could be even more effective. Have any of you ever tried to tickle yourself?
It's not ticklish.
Can't do it. Because if you tickle yourself, yourself is doing it. It's got like some bones that can attach you to the same thing as you're tickling it. So that's how you can't do it.
Well
Brilliant. So yeah,
done.
when you're tickling yourself, you know that it's you, right? And being ticklish relies on the element of surprise. It has to be a surprising feeling. Now this makes sense, doesn't it? Because back in old days, when we were all living in caves, in the sort of jungles, in the forest, then it would make sense for us to feel ticklish when it was a surprising feeling. Because that was likely to be some kind of creature who might bite us or sting us or scratch us. So we'd feel ticklish and then we'd flip it away and get rid of it. But imagine what would happen if over the years we also evolved to feel ticklish anytime anything was touching our skin. That wasn't a surprise. Think about what would happen every time you put on your shoes and socks. You'd fall about laughing, right? Because it would tickle. That would be really annoying. So our clever brain has evolved to be able to block the tickly feelings when it's our own hands on our own skin. And what it does is it makes a quick prediction about how our hands are going to feel and then blocks the tickly feelings. So the question is, how could we trick Lyra's, how could we trick Lyra's brain into thinking that my hands doing the tickling are actually her own hands, so it's no longer a surprise, so she can block the tickly feelings? Yes?
Tip your same fingers to her fingers and then tickle so it feels like it's her hand and actually it's yours.
Brilliant suggestion! So, if we ask Lyra to touch my fingers with her fingers, we don't need to tape it. It's actually simpler than that. Great idea, but we don't need to. Let's see if we can just do it simply by touching. So if we ask Lyra to touch my fingers with her fingers, whilst I tickle her, we'll do it in 1 second. Hopefully, her brain will know how it's going to feel because it will think it's her fingers and it will block the tickle response. Shall we try? Okay.
Tickling edition.
That's how you block a tickle. You can go back now.
It's a very simple little bit of science, but also psychology. Remember, psychology is a science. Even I thought at one point it wasn't.
Another one of my favourite facts. That fact is one of the facts in my book, Brain Fizzing Facts, which I can tell you about at the end. But my second favourite fact from that book is about something rather strange. Did you know that there is a creature that can breathe through its
Eyes, butt,
bottom?
through its butt.
Yes, seriously. There is a creature that can breathe through its bottom. Now, what I'm going to do with this one is something that I also do in the book to set it out so that you can kind of have a go at it yourself, is I'm going to give you a multiple choice selection for your answers so you can have a guess at what it could be. Now, the way that I lay this out when I explain facts is I give you suggestions that all could be kind of true, and we'll see if we can work out which one is true. So, do you think a creature that can breathe through its bottom, could that be a pufferfish?
A worm.
Could that be a dolphin? Could it be a turtle?
A worm.
Or could it be a frog?
Frog.
Hands up. Are you pointing at me?
No.
You giving me an answer?
No.
Hands up if you think it could be a pufferfish.
I think it's a frog.
Okay, so this is quite a sensible suggestion because fish indeed do breathe underwater. So they can't breathe air through their mouths like we do. So it might be sensible to think maybe they can breathe through their bottom. However, gentleman, young man over here is going to tell me that fish actually breathe through their yeah, the flappy things. Well done. They're called gills. So, good suggestion, but fish actually breathe by absorbing oxygen from the water through their gills into their bloodstream. So they don't breathe through their mouth, but they don't either breathe through their bottom. Okay, so who thinks the answer could be a dolphin? Oh, so why do you think it could be a dolphin? Gills, they don't actually have gills. Unlike fish, dolphins actually have lungs, like we do. And lungs are designed to take in air and to take out the oxygen from the air and then to breathe the air back out, usually through creatures' mouths. But of course, dolphins don't breathe in and out through their mouths because they spend a lot of time underwater. So, yes, well done. Dolphins, when they're underwater, when their mouth is underwater, they actually have an opening, a hole on the back of their body called a blowhole. And that sucks in oxygen, sucks in air, and then they suck in the oxygen, and then what do they do with the air once it's been used? They blow it out, exactly. So you might have seen, if you go past dolphins in the sea, or whales as well, they do the same. They can stay underwater for up to 20 minutes. And then they then shoot out the air that they've sucked in through their blowhole, and they go psh, into the air. A sort of turbocharged snot. And they shoot it out really, 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 really fast. I wouldn't suggest you go too close to a dolphin when it's shooting out its snot. So they don't breathe through their bottom either, they breathe through their blowhole. Okay, what about, who's not a frog? Oh, okay. Can anyone suggest why a frog might need to breathe through its bottom?
I believe some frogs can breathe through their skin, and the
So-
bottom is part of their skin.
So, very smart, yes. There are, oh no, I broke your flag, I'm sorry.
It's okay.
Can someone move the flag? So, you are absolutely right. So frogs do have to breathe through their skin, because like humans and dolphins, they have lungs, and they can take in air through their mouth when they're on land. However, they spend quite a lot of time, frogs, in the water. And then they can't breathe through their mouth because they're underwater or covered in water, but they can suck in oxygen through their skin. They have a special type of skin. So they can do both. They can breathe through their skin or absorb oxygen through their skin or through their mouth and lungs. However, that's not their bottom. So that leaves us with, can you remember what the fourth option was?
Pufferfish.
No, we did the fish. It was a
Turtle.
It was a turtle. So can anyone tell me why it must be, or how it could be that a turtle can breathe through its bottom? Any suggestions?
Because it's got a shell on its back. And they go underwater and they can't really go on land. And they've got a shell on their back so they can't get back.
That is a brilliant explanation. So they live not much time on the land. They live a lot of time in water, like the other creatures. They've got a shell on their back, so they don't have a blowhole. They've got thick, scaly skin, so they can't breathe through their skin like a frog. They don't have gills like a fish. So when they're stuck underwater, they don't really have many options left other than to breathe through their bottom. Now, certain types of turtles spend a lot of time underwater, particularly those that live in very cold areas, where during the winter, they hibernate under the surface of frozen lakes. So the top of the lake is covered with ice, and they hibernate under the surface, because it's warmer.
The heat goes up, not down, and with air the heat goes up, but in water the heat goes down. It's negative physics.
So what heat does actually go up in water, but it's the fact that you're almost right. It's the fact that when a lake is frozen, there's a top layer of ice, and underneath the water actually stays a little bit warmer than on top. So the turtles hibernate for up to 5 months under this layer of ice. But how do they breathe? So they've developed a very special technique of sucking in air through their bottom, then absorbing the oxygen from the air, kind of like how fish do with their gills, but through the inside of their bottom, and then they scoosh the water back out with the dissolved products of their respiration system, which is, as many people might know, carbon dioxide. They scoosh the air back out, and then they suck more in. And they can do this up to 60 times every minute.
Wow.
This is like in and out through their bottom, sort of bottom breathing for 5 months at a time in order to get their oxygen whilst they're hibernating under a frozen lake.
Wow.
There are lots of other creatures that do all sorts of strange things with their bottoms, but I'm afraid you're going to have to read my book to find that one out, because I want to move on to tell you that the reason that I'm sharing some of these facts with you today, the reason that I'm here today on this very cold, wet Monday afternoon, very damp, and the reason that hopefully you're all here too, which is really wonderful to see you here today, is that all the things I've been talking to you about basically shows us that we are all connected and linked to nature. These things that we've been talking about, turtles and fish and dolphins, these aren't just things that we go and see on the television or in a zoo, but actually they exist in the world around us. And we have a role, we have a responsibility to look after these creatures in the world around us, because of course we are all interconnected. It's like a sort of game of Jenga. Every piece is connected to the others. So if you were to pull just one piece out of the game of Jenga, everything falls down. And in science, what we call this ecosystems, or food webs.
Interdependency.
And everything depends on everything else. We may feel like a turtle living under a lake somewhere is very far away, but actually we're all connected. A lovely example of this is there's a park in America called Yellowstone Park. And in this park, quite a long time ago, about 100 years ago, the rangers killed all the wolves because they didn't like the wolves, and the wolves were like hunting some of the creatures. But this was not a good idea, because what happened as a result, they killed all the wolves, but then the creatures that the wolves usually ate, which are called elks, they're kind of like a big sort of deer, those creatures suddenly had no one to eat them. So there was suddenly lots and lots and lots and lots of elk. Now this is a good thing if you're an elk, but what that meant is that then all the plants that the elk eat suddenly all got eaten. So the elk eat the plants and the trees, and they all started to disappear. Now as a result of that, first of all, lots of songbirds started to disappear because they had nowhere to live. There were no trees for the birds to live in. Also, the same plants that the elk eat were also eaten by beavers. Now, that meant that lots of the beavers could no longer survive because they didn't have any food left. Beavers make dams in rivers, and the dams in the rivers are required in order for fish to live in the rivers. So once the beavers had died, then the fish started to die. So you can see, so I'm a bit scared of this. Thank you, you just say that. So you can see that with... It's okay, it's good if it's a short one. It's like a fishing rod.
Yay, and less eye pointy.
So, what's that?
And less options of pointing at eyes.
Yes, definitely. So, hopefully you can tell by this story that if you change just one creature in a system, then actually lots of the other creatures can also have impact, can also be affected. Similarly, if we were to do something, if we were to pour a tin of paint into your drains here, that could flow into the rivers, that could end up in the oceans, and that could affect sea creatures or fish across the other side of the world eventually. So we're all connected to the world around us through different ecosystems. Now, the reason that's important is because we actually depend on the natural world. Can anyone tell me the ways in which we depend on the world around us? Yes. Yeah. For food, so an important one is for food. We eat grains and plants and vegetables that are grown from the land. We also, some of us eat meat and dairy, and of course indirectly, I know that's not a good thing, let's talk about that in a minute. Indirectly, we also depend on the land for our food, because in order to grow food, like crops, the land needs to be good and strong, there needs to be good soil.
Yeah.
And
Can't use
pesticides.
pesticides.
It's important that we keep healthy so that we can grow our food and so that we can all have enough to eat. How else do we depend on the world around us?
We need water.
We need fresh water, exactly. So we need to make sure we don't pollute our water. And we need to make sure it's good water for us to drink, and also for all the creatures who live in water, in the seas, in the rivers, in the ponds, in the ocean. We need to make sure that they have healthy water so that they can survive. Because of course, all of those creatures are then impacting all the other creatures that also going to be on the land and the water. Any other ways in which we depend on the natural world around us? So for food, for water,
Clean air.
For more food, absolutely, lots of food from the land. Yeah.
Houses.
For houses, so areas to live on, we need space to live.
Clean
Anything
air.
else?
Shelter.
For shelter, wonderful.
Air.
So sometimes we need trees to help to protect us from storms. Anything else? We need the sun so that we're warm, and we need to make sure we're getting the right amount of sun so that we're warm enough, but not too hot. Lovely. Anything else? Wonderful. We need the trees so we can breathe. So trees are very important because to breathe we need oxygen from the
Trees.
the oxygen. Sorry, I set you up for that one. We need oxygen from what?
Photosynthesis.
From well, yeah, okay, we'll come to that. But basically, we need oxygen from the air. We need clean air. So clean air means that we need to be careful that we don't pollute the air. But it also means that we need to not only take in oxygen from clean air, but we need to make sure that what we breathe out, which is carbon dioxide, is then taken back in, and the best creatures to take that back in are trees and plants and leaves.
Green leaf.
Green leaves, exactly. So trees are very important because they absorb carbon dioxide from the air, they lock it into their trunks and their leaves, and they give back out oxygen, which is what we need in order to breathe. So we're very dependent on our natural world around us for very many reasons. Yes?
Algae.
Yes. Sea algae.
Sea
So
algae,
phytoplankton.
wonderful. Great example.
74%.
Algae in the sea. So we need the seas, the land, the air to be healthy, not just because we love the creatures in those worlds, but because we depend on it for our own survival. So what is it that we humans do or at the moment that impacts? What impacts do we have on the natural world around us that might impact the wolves or the fish or the turtles or the dolphins? What do we do? Right, so for example, there are many creatures on this planet that are dying out, that are going extinct because of human action, because of the things that we're doing to hunt them or to eat them or to remove their habitats by cutting down trees so they've got nowhere to live. So we're impacting creatures on this planet by using land to grow crops or for grazing cattle, to feed us with beef and lamb, and we're getting rid of the natural places where some of our natural creatures live. How else are we impacting the world around us?
We're taking down the rainforest.
Wonderful, great example. So humans are cutting down trees. Now,
Quanto è
this has been
stupido,
important
no?
in history because we've needed some of those trees to build houses or to use the wood, but actually we're removing lots and lots of trees these days. And not only does that mean that they can't suck in the carbon dioxide for us, but it means that there's nowhere for lots of other animals to shelter. And also when we burn those trees, if we simply clear the area, when we burn the trees, it releases even more carbon dioxide into the atmosphere. So this is a real challenge. Anything else we're doing to the world around us? So, okay, great. So pollution. So things we're letting chemicals
Oil
into our
spills.
rivers, into our oceans, into the land. Then of course things like cows and sheep eat the land, they eat the grass, they suck up some of that pollution. It ends up in rivers and seas, and it pollutes the fish, and that could end up actually affecting us directly because either they will die or they end up with chemicals in them that are not so good for us to eat. So these are other impacts. Yes, any more impacts? Yeah.
Too much plastic.
Great.
Yes.
So we're using a lot of plastic. And what is it that's so challenging about our use of plastic? What is it that's bad, really, about the fact that we're using so much plastic? Anyone?
Because then, like, the fish and other animals eat it, and then we eat it, and then we get plastic in us.
Great. So one problem with plastics is that yes, they can end up in the stomachs of fish, and then we can eat it, what's called microplastics, tiny little bits of plastic, and then that can damage us. But even well, not worse, but another really important thing about plastic is what? Yeah. Oh, okay, we can come back.
Yeah, so we build
too many houses. Yeah, so when we build houses, we're using up the resources on this planet. We're using up the things that our planet supplies us, and it hasn't got enough. So it's running out of raw materials and resources to make things. Going back to plastic, would anyone mind just making sure this doesn't keep coming down? Is that all right? Sorry, thank you. So with the plastics, yeah, tell me about plastic. Yeah, so we end up with microplastics in the water, but even before they break down, the problem is plastic itself. Yeah, great. Plastic itself doesn't biodegrade. It doesn't go away. So when you throw plastic in the bin, it doesn't go anywhere. It just ends up in the sea or in the oceans or in big landfill areas. The same really with anything you throw away. It doesn't disappear. There's no such thing as a way, really. And especially bad for plastics, because plastic you throw away here could end up in oceans across the other side of the world. So there's many ways in which we are directly and indirectly impacting our planet. Can anyone tell me one more way? Yep.
Oil spills.
Cars, because you could suck up the pollution from cars and die.
Right, so cars,
Even when you go underwater and you see plastic, and you eat fish and then you die.
right, yeah, so fish could be really harmed by that. So, one more thing.
I'm not sure if this is true, but there might actually be as much fumes as there is in a packet of cigarettes when you're walking in the city to and from school.
Great, so some great examples of how human action can impact our air, but also mentioning cars, it's also important that we are aware that what humans also do is they burn things called fossil fuels. Anyone heard of fossil fuels? And what's the problem? Like cars burn petrol is a fossil fuel. Apart from polluting our air, which we've talked about, can anyone tell me why burning fossil fuels is actually causing some problems on our earth right now?
It can explode houses.
Okay, so using gas in houses could cause explosions, but that's quite rare, so I don't think we need to be too worried about that. But can anyone else do something about fossil fuels? Go on then.
Carbon dioxide just burns the ozone layer and it's too much heat of the sun.
Brilliant, so carbon dioxide is the key here. So when humans burn fossil fuels by driving cars or flying airplanes or making factories to make clothes or to make produce, then what happens is those fossil fuels release carbon dioxide, and that carbon dioxide goes into the atmosphere, and there's a layer of gases around the atmosphere, not the ozone layer, but a layer called greenhouse gases. And that layer is actually good. It's good that we've got greenhouse gases like carbon dioxide in our atmosphere, because it provides like a little warm blanket around our Earth that keeps us warm. Without it, it would be so cold at night that we wouldn't be able to survive here. So it's actually really good that we have greenhouse gases. However, when we burn these fossil fuels and we cut down trees, we're putting more carbon dioxide into the atmosphere than there should be, and the fluffy blanket is getting bigger, thicker, which means we're getting even warmer. We're trapping too much heat from the sun. That causes the atmosphere to warm up a little bit, and that warming is what can cause, for example, extreme weather, lots more rain than usual, lots of floods, heat waves. It can also cause the oceans to warm up, and that means they're expanding, they're taking up more space, and it can also cause changes to the chemicals in the seas, which means that creatures can die, and it can also cause melting of ice. And in fact, there's so much ice melting on our planet that if you average it out over the last 40 years, the amount of ice that's melting is 300 double-decker buses worth of ice melting every second. That's how much ice is melting on this planet. 300 double-decker bus worth of ice every second. So it's really important that as human beings we're aware of the damage that we're doing to our natural world, but what's great is that we can do something about it. So before I finish, can anyone just tell me a few things that we can do, even as children or as adults and teachers, some things that we can do to help to protect the planet, to help to look after the planet, so that we're not doing so much damage in the future? Yes?
Stop eating so much meat.
Great, because we talked about the fact that beef and dairy and lamb, cows and sheep are all grazed on land that used to be forest. Also, the problem with eating beef, did you know there's another greenhouse gas, not just carbon dioxide, there's another greenhouse gas called methane. Now cows, because of the way their burps and farts release methane. Did you know that one single cow in one day can burp enough methane to fill 15 party balloons full of methane? One cow! Think of how many cows there are on the planet. So, we can do a lot to help the planet. We can eat less beef and meat and dairy. We can eat more vegetables and fruit. We can make sure that we use less cars and less flights, so we're burning fewer fossil fuels.
And stop using plastic, people.
We can stop using plastic.
Ban single-use plastic.
We recycle. We can also make sure we don't use as much stuff generally, because everything we use is created by burning fossil fuels. So if you don't need a new thing, use the one you've got already, or give it to someone else, or buy something second-hand, or mend it. So we really need to stop using so much, taking so much from the planet, and just making the most of what we actually have. Any final points, because I'm being asked to stop? Any final points down here?
If you grow your own food, it's better because supermarkets are wrapping it.
Grow your own food so that supermarkets have to wrap it in plastic, and also it stops the air pollution from aeroplanes that fly in food from somewhere else. So grow our own food. And finally, aligned with that, yes?
I think use your because 50% of our emissions are done for us by actually being in this society.
Yeah, great final point. So I was going to say one last point is that we need more trees, so we can plant trees. But actually what's really important to realise is that it's important we do all these things, but actually we really can't do enough alone. And that brings me finally to why we're here today. Because actually a lot of our greenhouse gas emissions, our fossil fuel use, is not through individual use. It's through governments, it's through subsidies, abroad, overseas, it's through investments in our banking system. Actually, that's where a lot of the fossil fuels come from. So yes, it's important that we protect the world around us, that we look after our planet, but what's even more important is that we use our voices and we take action. And even small people can make a difference. You can work, you can take action in your school to look after the planet, you can come on protests like this. Look at Greta Thunberg, 16 years old. Look what a difference she's made by using her voice, to use her influence, to talk to grown-ups, to talk to people in Parliament, people at the United Nations, your parents, your teachers. Share with them how you feel, help them to make a difference too. So thank you so much for being here on the streets. Thank you so much for taking part in this protest, for being here today. Continue to use your voice. Continue to teach others about the impacts that we're having on our planet. And thank you for listening. If you want to know more about, if you want to know more about me, my name's Dr. Emily Grossman. My work as a science communicator is to educate young people, teenagers and adults about the climate situation and the ecological situation. I also do lots of other science talks in schools and universities, but this is the thing right now that I'm most passionate about. If you're interested in reading or hearing more about my work, I've got some of my books here that you can have a look at, or you can buy if you've got any cash on you. Or I've also got some flyers if there's any teachers here who might like me to come into your school, or if you've got parents who can take, go and talk to your teachers, or just come and get some information about me. I'm also one of the coordinators of a group called Scientists for Extinction Rebellion, and we're all about getting the truth out there about the science of the climate and ecological emergency. You can follow us on Facebook, or you can follow us on Twitter. Thank you so much for being here, everyone. Enjoy the rest of your afternoon.
Thank you.
Thank you so much.
So for those just joining in, this is Extinction Rebellion. You know, we are here in front of the Department of Education today, which is funny enough directly across the Adam Smith Institute. So sorry for the sound. You know, they are being a little bit spiteful. You can go and read up the definition of spite. They are being a little bit childish and silly as well, just like the neoliberal ideology. You know, it's not really based on science. But yeah, you know, so over here instead, you know, we have educators, we have people working at universities, people working in schools, you know, and educators. You've just heard Emily Grossman. You know, she's part of she's a scientist. You know, PhD in science, but we're also calling on all the other scientists. You know, if you have a PhD or master's degree in any one of the sciences, so baccalaureate science, a BSc degree, well, even, you know, economics, although it's not really a science, it's more of an ideology. But funny thing is, we did start the fires, and it they are being so funny, so silly. They are the anarchists. Funny. You are the anarchist, Adam Smith Institute. You do not know it, but you are literally destroying the planet. So let me just go through here. Again, this is